Hello everyone, this is Sabin and today I'm going to present about my project titled Assessing Performance of Pocket Lidar for Coastal Monitoring. So every year coastlines around the world are reshaped by waves, winds and major storm events, and monitoring these changes is essential not just for protecting habitats and infrastructure around the coast but also for preparing for future sea level rise and managing sediment budgets. And traditionally we used to measure mm, and monitor coast from and survey instruments like terrestrial scanner, GNSS, and drones. But they're they're precise, but they have some limitations like they're expensive, require trained operators, and some complexity. And I'm testing a technology which many of us already carry, the iPad Pro. So inside of iPad Pro, there is tiny lidar sensor. It was released in 2020, and it can measure up to 5 meter depth. Uh, So the studies site that I tested is in University Beach, and two different data sets from two different dates were used, like terrestrial laser scanner, pocket lidar, and also yeah, GNSS, RTK GNSS data, real-time kinematic data for uh, ground control. And since iPad Pro has some limitations, I divided the study area into two different sections for September, and for February, five different sections because there was a lot more beach than that in September. So the methodology is TLS data was processed in Rescan Pro using manual alignment. Uh, there were different scan positions. On the left we have terrestrial scan point cloud, and on the right we have pocket lidar point cloud for two different dates, uh, and some conceptual workflow on the right. And different softwares used were Cloud Compare, Pixpodimatic, ArcGIS Pro. Mainly Pixpodimatic was used for processing pocket lidar data, like generating point clouds, and later uh, Cloud Compare was used for noise filtering, uh, creating digital elevation model at 5 centimeter resolution, and comparing cloud to cloud with terrestrial laser scan point cloud, yeah, and things like that. So basically, at the end, the purpose was to calculate cloud field volume and access. And for September data sets, some of the important results that was noting is that if a LiDAR um, produced some rugged um, digital elevation model, then TLS, like we can see some inconsistencies in TM produced by Apple LiDAR. And so although the heater was up to 10 centimeters, it's comparing to TLS and GNSS as ground truth. Uh, we can also see the difference of DEM. The yellow area indicates nearly non difference between both of them. So this can introduce more challenges, as we can see in the DEM that it introduces more noises, and uh, TLS showed slight more accretion while pocket lidar showed uh, erosion. So there is some inconsistencies. I believe that it is due to the February scan being larger area and wider field. Going back and forth, it is more error. So to conclude, I've included some major advantages like low cost, rapid, accessible, portable, and require minimal training. Some challenges like insufficient overlap and drifts due to a area being larger, and some vertical misalignment in the DEM or point cloud that we generated. And some recommendation would be to target small areas, moving at constant speed and height, and try covering maximum overlap. Future research can explore the integration of RDK enabled device we can capture up to centimeter level accuracy. So thank you. That's my time.